Hello, so I'm going to be doing my final video summary. So with misconceptions, let's see. So explain what a misconception is as it relates to science instruction. Be specific and give examples of at least 2 common science misconceptions. Okay, so a misconception is an event or I cannot talk. An opinion or a view that is incorrect and wrong in one's eyes, and it's based on wrong thinkings or wrongdoings and understanding of a subject, in this case science. Okay, so one misconception in science that students might have is that ideas are just too abstract for them and difficult, because many students are still at a concrete learning stage, aka me. I do take longer to process things, and in this case, this is kind of hard for me to talk about because I get the concept of misconceptions, but I don't know how to explain it well and in my own words, because I am still processing what it is, even though we've talked about it a lot. So it says right here, this is from the article that we were given in our misconceptions assignment. That empty space between atoms and molecules, it's kind of hard to understand. And for me, I kind of forgot all about that. Sorry, I like to talk with my hands too. And also, memorization of ideas can be more difficult, and particularly for academically good students. For me, memorization is also hard, and that's why I don't do good on tests or anything. And luckily, we didn't really have any tests in this class, because I do have test anxiety. I've been diagnosed with it since beginning of high school, so for me, that is kind of true. Okay, so question number 2. Please explain how you will leverage student misconceptions of common science phenomena in your future classroom to help teach those students. So this kind of is hard to do, because once a student has learned something at a young age, it is hard for them to process changing what they believe and what they've thought for many years. So one way that I will help teach my students about their common misconceptions is that I will not tell them that they are wrong. I will simply give them multiple reasons of why I think, and how I will try to change their beliefs. So one common misconception is that trees are only considered plants when they're small. So if they have this misconception, I would show them multiple pictures and multiple facts and articles and proof that trees are considered plants even if they aren't small. Hope that made sense. So please explain what the term progression of the standards means in regards to the NGSS. Be specific and give details of at least one linear progression of a DCI from K through middle school. So progression of the standards. So that, to me, that means you have to progress through the standards. So starting at the first concept, so the first standard in the science standards are K-PS2, so motion and stability, forces and interactions. So you must progress through that first standard and then move on to the next standard, and so that students can comprehend and stay on track. And that the DCI, those are the disciplinary core ideas. And so those are grouped into the 4 domains, which are the physical sciences, the life sciences, the space sciences, and the engineering, technology, and applications of science. So those ideas have to meet certain criteria to be considered core ideas. And so in this case, with the first standard, K-P S2-1. So plan and conduct an investigation to compare the effects of different strengths or different directions of pushes and pulls on the motion of an object. And so the disciplinary core idea that goes with this standard is going to be pushes and pulls can have different strengths and directions. Also, another one that goes with this one is pushing or pulling of an object can change the speed or direction of its motion and can start or stop it. Another one is when objects touch or collide, they push on one another and can change motion. And there is one more, which is a bigger push or pull makes things speed up or slow down more quickly. So for a student to fully understand this standard, they need to learn the DCI, the disciplinary core idea. And so they must be able to achieve that DCI in order to understand that standard and move on to the next standards and progress in learning. All right, so please explain what the role would be as a 5th grade teacher focused on teaching content related to the NGS Performance Expectation 5-PS1-3. And that standard is going to be make observations and measurements to identify materials based on their properties. So with this standard, you want to be able to nail these 3 other things, which is the science and engineering practices, the DCI, and the cross-cutting concept. So with these, each standard has 3 of those that they want you to be able to teach your students, and that will be able to determine if they move on, if they understand these concepts that go with it. So in this case, the engineering practice is going to be make observations and measurements to produce data to serve as the basis for evidence for an explanation of a phenomenon. And then there's also a DCI and cross-cutting concept, which I mentioned before. These won't always align with your standard and what you are teaching on, so you can change these out. But in this case, I just use those because of the examples that they gave. So for students to be able to understand this standard beforehand in grades before, they must be able to understand that energy and forces and about molecules and atoms. And then after, when they are in middle school, they will be able to understand that pure substances have characteristic physical and chemical properties and are made up of a single type of molecule and atom. Okay, the 5E learning cycle, which is something I'm grateful that I learned about this semester. Please explain the desired outcome for each of the 5 stages of the 5E learning cycle in detail. So the first phase is going to be engagement. This is where you want to grasp your students' attention, maybe start out with a cool attention getter, a funny video, something that they'll be intrigued to learn more about, and they will stay on task the entire time. Next phase is going to be the explore phase. In this phase, you want to have your students explore in a way like a hands-on activity. You want to set them up to fail the first time so then they can reconstruct and kind of process why you set them up to fail and what they can do to change to make it succeed. In the explanation phase, this is where you're going to have the convergent question sequences. So just asking them questions like, why did you fail the first time? And what changes did you make to make your design succeed? So in the elaborate phase, this is going to be where you want them to do kind of like another activity, to just kind of keep them exploring. And yeah, so an example of this, I know everyone does it, but like Flipgrid. So having them, show off what they did in the explore phase, why they did it, blah, blah, blah. And then the last phase is going to be evaluation, and this is going to be your assessment tools. So you can assess them on their cognitive, psychomotor, or affective abilities. Next topic is the engineering design process. So the engineering design process. This is probably the my favorite thing I learned throughout the semester. So you first want to ask and identify the need and constraints of the process. Then you want to research the problem. Then you want to design a possible solution for the problem given. Then you're going to plan it out and build like a prototype, build it up. Then you're going to test your prototype, and you're going to improve it to make it better. So that's the engineering design process. So some examples with, I did my teaching on my group teach on the stranded horse lesson. So this was an engineering design process standard that we used for our lesson. So the problem was that there were stranded horses in California during the fires, and what would we design that we wouldn't hurt ourselves as people in order to save the horses that were stranded. So we did the iPads, and they had to build a robot that would be able to carry and have enough pull to carry the large horses that were stranded. So we set them up to fail the first time, where they had to use their phone, and we knew it wasn't going to hold it, and so they had to, reconstruct it and make it better and improve it in order to succeed and save the horses. And that meant adding different wheels to their robots. I forgot to mention in the last clip. So explain your rationale for where in the process deep learning occurs and why. So I believe that the deep learning occurs in the reconstruction phase, because this is where they are all coming together and you are building solutions on how to make it better and improve it. So feedback. First off, I just want to say that this semester was very tough. There's a lot of assignments and a lot going on, but I just want to say thank you for being an awesome teacher and making science fun to learn about. I've always struggled with science. It's not been a subject that I've been very excited to teach in the future, and you've made it fun and engaging. And as much as I hated getting up at 8 a.m., it was fun, and I loved my class and you as a teacher. So thank you for an awesome semester. I'm really looking forward to teaching science in the future now, because I understand a little bit more how to teach it now. Last question. So what assignment did you feel was the most helpful, impactful, and why? I would have to say this assignment, because I'm not one to talk in class. I don't like to share my thoughts in class. That's just a personal thing, also with my anxiety and stuff. So this assignment was very helpful and impactful, because I just felt like I could personally talk to you and explain what I learned throughout the semester and what I liked. So yeah. And then the last one, what assignment do you feel was not helpful, impactful enough for me to repeat in future semesters, and why? I honestly have nothing this semester, and in class was amazing, and I will cherish every moment I had in this class. So thank you. This is Alexandra Scribner, and I am signing off. Thank you for an amazing semester.